So hopefully you can hear me. Hopefully you can see this. Hopefully it started. Should have done by now. So we have not got long until paper 3. We've got, looking at the time, at 2 days, 22 hours, 27 minutes. So not long really at all. So what I'm going to go through today is some predictions, some predicted papers, or predicted topics rather, and some questions for those. Okay, so these predicted topics are from the same place as last time, so they're from a place called First Class Maths, which have done all the analysis and made these predictions. Now, these predictions are not necessarily, or not definitely, on the paper, but based off of what's happened previously, it gives a good indication of what's likely to be on the next papers coming up. Okay, so what I'm going to do is give you a few minutes to have a look at these warm-up questions just while people join, and just while people are thinking about those. I'll give you a couple of minutes or so, and then we'll get started on looking at actually how to do these questions, but also the predictions. What's going to be on paper 3, or what we think is going to be on paper 3. Okay. Right, so a few minutes, and then what we're going to do is we're going to go through the topics, predicted topics on paper 3, and then questions that are on generally, well, as many as we can, AQA and Edexcel papers, higher foundation, both of them, so that's suitable for everyone. Now these sessions are suitable for, like I say, AQA, Edexcel, OCR, although I don't have any predictions for OCR, and higher foundation. I will also be doing on the night before paper 3, so Tuesday night, basically some more practice, some last minute things, some things that you might want to look at, you might not want to do, you might think actually, I hadn't thought about that, so just some last minute practice, ideas, and just basically some, going through some questions essentially, which would hopefully and should, if you are nervous, which you shouldn't be because at this point you've done loads of revision, relax you and give you some hints and tips of what to do like I did with paper 2. Okay, 30 more seconds, then I'm going to go through these questions. There are suggested websites on the screen as well. You can see there's the breakdown of the topics on higher foundation and those recommended websites, and of course if you want to, you can buy me a coffee to support the channel. It's very much appreciated, or just like and subscribe is as much that I can ask really. Okay, right, so let's get started on these questions, and these are again they're on the predictions. They might not be for your exam board, they might be, but I've tried to pick ones. I've tried to go through and analyse it basically so that I'm doing topics that are on as many of these, or predicted to be on as many of these tests as possible. Okay, highest common factor and lowest common multiple. Now, the way that I would suggest to do these is different really depending on whether you have got larger numbers or smaller numbers, and in the question if you've just got highest common factor or just lowest common multiple. Because if you're just working out one of them and they're smaller numbers, then what I would do is list your factors or list your multiples and find the highest common factor or the lowest common multiple that way. Now with these numbers, because they are relatively large, they're going to have quite a few factors and the multiples are going to be a bit more difficult to work out. What I would suggest doing is the prime factor decomposition. Just turn the lamp on, remember that wasn't on last time. The prime factor decomposition of both of these numbers, and then using a Venn diagram. So I'm going to go with 2 times by 42 and then carry my 2 down. Now 42 is 6 times 7. So you're splitting your numbers up until you get down to prime numbers, and when you do get prime numbers you circle them. 6 is 2 times 3, and then I've still got that 7 there as well. So all in all, 84 is 2 times 2 times 3 times 7. Now I need to do the same thing with 120. So if you can not use prime numbers at the start, that will help break it down quicker. You'll end up with fewer rows, essentially. But if you just do 2, 2, 2, you're going to have quite a lot of rows. That's fine, doesn't matter. It's just if you're thinking about space or being quick, I suppose. So here I could go with 40 and 3. I'm not sure what else to go with, so to save time I'm going to go with 3 and 40, because 3 is better than 2. It's going to hopefully reduce the number of lines I'm going to have to do, because it's going to break this up a little bit more, I suppose. So 3, 3, and then we've got 2 times 20, but what about 4 times by 5? So 5 is a prime number, so 3, 2 times 2, and then times 5. Now actually, because they always ended up with one of them being prime, it wouldn't have reduced the number of lines there anyway, but it doesn't matter. You know, don't overthink it, it's just something to be aware of. So 2 times 2 times 3 times 5. Okay, now what I need to do, because I've got both prime factor decompositions, is put them in a Venn diagram. And this is only a working out, so it doesn't need to be the most beautiful thing in the world ever. It just needs to be readable for yourself and hopefully the person marking it, in case you make a mistake in your answer. So 84, I've got 2 2's in 84 and 120, and I've got 3 in both. So I'm going to cross 1 2 out on both and put a 2 in the middle. Cross another 2 out on both and put another 2 in the middle. Cross a 3 out on both, and that's going to go in the middle, squeeze it in. And then for 84 I've got a 7. Okay, and then 120 I've got a 5. Now I do just want to check this, because this doesn't make much sense to me, at least, because in the middle I've got 2 times 2, which is 4, times by 3 is 12, 12 times 7, that would give me 84, but 12 times 5 would give me 60, so I've made a mistake somewhere, and that's a way you can check it. There's another way you can check these as well on your calculator. So 40, I've missed out, I did 4 times 5, that should have been 4 times 10. So if I do, basically if I make that 4 times 10, I'll do it over here, 4 times 10, and that will give me 5 and 2, and then I end up with another 2 down here. Now that means I've got another 2 in here, but also what that means you need to check is that you need to check this does multiply to give you this number, this does multiply to give you this number. Another way you can do this on your calculator, and I will actually show you on this one, because this one is probably the same layout that most people will have. So if I type in 120, press equals, and then I've got that number there, and then there should be a fact button in yellow, which is above. Now I said this was the similar layout to what most people have. It's not, because the fact button's usually around here somewhere. I can't seem to find it on this calculator, which may mean it doesn't do it, because it's an older version than what most people have. So that one actually may not do it. Your one probably will, because this is quite an old calculator. If I do it on this one, this is slightly different now. This is the brand new one. 120, get it as your answer. Now if I go to format, I can go to prime factor, and it will do it for me. Okay, so 2 cubes, because I've got 3 2's, a 3 and a 5. Okay, 84, format, prime factor. Now you can do this probably, most likely on your calculator. You just need to type in your number, and then press shift, and then it will be in yellow somewhere around here above one of your buttons. Okay, that's a way to check, because obviously paper 3 is a calculator paper. Okay, now highest common factor is the bit in the middle, so 2 times 2 times 3. So that is 2 times 2 is 4, times 3 is 12. That's the biggest number that we can divide both of these by. Lowest common multiple is all of them times together. So I've got, well, the middle is 12. I've got 7 times 12, the middle, times by 2 times 5, times all your numbers together. Now if I do that on my calculator, because I can't bother to do that on my head, 7 times 12 times 2 times by 5 gives me 840. That's the lowest common multiple, the smallest number that is in both of the times tables of 84 and 120. Okay, next question here, make y the subject of the formula. So, x is equal to 3y minus 2. What I need to do is undo each of the operations until I end up with y equals. So I want to add 2 to both sides here. And then I'll end up with x plus 2 is equal to 3y, and the minus 2 and the plus 2 cancel out. And then, because it's 3y, 3 times y, you want to divide by 3 on both sides. Okay, I can't do it underneath there because I've run out of space. What you'll get then is x plus 2 divided by 3. Do the whole thing divided by 3 is equal to 3y divided by 3, which is just y. And that's my answer. The next question I've got here is solving, and it says give your solutions correct to 3 significant figures. So solving a quadratic, because the highest power is 2, 3 significant figures. That suggests to me that it's not going to be nice whole numbers, which suggests I won't be able to factorise it, and so I will have to use the quadratic formula. Now, if you don't know the quadratic formula, and you're doing the higher paper, then you'll need to know this. Minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Now that's where a is my number in front of the x squared, b is the number in front of x, and c is the constant term at the end. So for me, a is 3, b is negative 11, and c is negative 13. Okay, so I'm going to get minus negative 11 plus or minus the square root of negative 11 squared minus 4 times by a, which is 3, times by c, which is negative 13, and that whole thing is square rooted, all divided by 2a, so 2 times 3. So I'm going to type that into my calculator, and I'll just change plus to a minus and minus to a plus, depending on which one I do first, and that will give me 2 answers. And that will tell me what x is. So x is equal to, I'm going to type this into my calculator. Excuse me. Now, with the negatives, I would always put them in brackets so that you don't make a mistake, and also it helps to recognise that that is the number. That's the operation there, that's the number. So fraction button first, minus negative 11 plus or minus the square root of negative 11 squared. Now if you don't put that negative 11 in brackets and you square it, you'll end up with a negative number, and then this whole thing won't work. You'll end up with what's called a maths error because you're trying to square root a negative. Minus 4 times 3 times negative 13 divided by 2 times 3. And that gives me 4.61, 3 significant figures. Or x is equal to, now I need to change, so scroll through, press the right button on the D-pad, get to the plus, change it to a minus, and I get negative 0.94. Okay, they're my 2 answers to 3 significant figures. Okay, and the last one says work out the length of AB, where AB is obviously this side. Now that is opposite my angle here. I've got an angle, I've got 2 sides, and working out another side, so in total 3 sides and an angle, and it doesn't have a right angle in it, so I can't use SOHCAHTOA. I'm going to need to use something else, so it's either going to be sine rule or cosine rule, and as I've got 3 sides, or I'm looking for 3 sides and an angle, that's going to be cosine rule. Remember, sine rule is all about sides opposite angles, sides opposite angles. I don't have any sides opposite any angles that I know, so I can't use that. So cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a, and you should be given this in the formula sheet, but you will need to rearrange it if you're looking for the angles. You'll need to know how to do that. Now a is opposite a, so capital A is opposite lowercase a, and obviously capital A is the angle, so lowercase a must be this side, that is capital A, B and C, doesn't matter which one they are, doesn't matter, because obviously you're adding, doesn't matter which way around you add, and times, doesn't matter which way around you times. So, doesn't matter what they are. So, A squared is equal to 15 squared, B squared, plus 12 squared, minus 2 times 15 times 12 times by cos A, which is 20. So, A squared is equal to this thing on my calculator. I will get to the predictions shortly, I promise you. Haven't forgotten about them. 12 squared minus 2 times 15 times 12 times by cos 20. So I get 30.71. Keep that on your calculator. You don't want to delete it because you're going to square root that now. Square root, and then the answer button's in a weird place on this calculator. 5.54, or 5.5, it wants it to one decimal place. And that's going to be centimetres because the rest are in centimetres. Okay, and make sure it makes sense. So look at your diagram, look at your numbers. Does that make sense? 5.5, 12 and 15, yes. If it was 30, probably wouldn't make sense because 20 degrees is a small angle. You're going to end up with a small side, short side. So it's probably going to be shorter than those two. So yeah, makes sense. Right. Now, without further ado, let's have a look at these predictions. So, starting off with AQA. Now, we went through these with paper 2. As a reminder, 5 stars are the most likely topics in their opinion to appear, and 1 star is the least likely topics to appear. I've only put on here 5, 4 and 3 star topics, because I think if you're getting down to the 1 star and 2 star topics, you're probably going to be covering those in your exam revision anyway, and they're less likely to come up so in first class maths opinion. So in terms of the 5 star things, so AQA higher, area of shapes, index laws, so that's your powers, your times you add, you divide, you subtract, inside and outside your brackets you multiply, highest common factor, lowest common multiple we've just looked at, so Venn diagrams, if you're dealing with like medium to big numbers, density, mass and volume. So look at the units for these. These will usually give away the equation, but also you've got your triangle, haven't you? Okay. Density is how tightly packed something in is. So basically it's how much mass for an amount of volume. Okay. Usually something like meters cubed or centimeters cubed. How much mass each little cube of volume has. Okay. Right, and the next thing, factorising, so that could be into one bracket, it could be double brackets. Solving quadratic equations, so that could be with a quadratic formula, or it could be putting a quadratic equation into double brackets, factorising it, and then basically you will end up, in most cases, doing the negative of the number in the brackets, unless you've got something like 2x plus 1. Then you have to divide, you have to do the negative and then divide by the number in front of your x. Write as a percentage or as a fraction. So put your number out of the total, gives it as a fraction, change it to a percentage times 100. Ratio to a fraction to a percentage, converting between all three of those things there. It's easiest to go from a ratio to a fraction and then change the fraction to percentage. Column vectors, so they're going to be in brackets, number at the top, number at the bottom. If it's like 3 at the top, 4 at the bottom, that means 3 right, 4 up. Error intervals, that's your lower bound, upper bound, and then you've got your inequality symbols and usually something like x or another letter in between. Speed time graphs, so remember the rate of change with those represents acceleration, and if it asks for rate of change with a speed time or distance time graph, then what it's asking for is the gradient. Direct and inverse proportion. Now make sure you know the equations, and also make sure that if you were to do it, numerically, or they give you like a worded problem, that you can do it with kind of proportion. So if it's direct, times by, if it's inverse, you times on one side, divide on the other. And you've got to think about the problem, such as, builders or a machine making something would be direct proportion, builders making something would be inverse proportion, generally. because the fewer people you've got, the longer it's going to take. But if you're thinking about a machine making something, the more machines you've got, the more you can make. Something like that. Some problem like that. Now vectors are very similar to column vectors up here, but that would be not giving it as a column vector, but actually as a diagram and saying that is A or 2A, and that's minus B, or so on. Sine rule, we spoke about that earlier. Cosine rule we've looked at. Half AB sine C is for the area of a triangle that isn't right angled. Similar area and volume. So get your length scale factor. So if you've got an area scale factor, square root it to get your length scale factor, and then cube it to get your volume scale factor. Cumulative frequency. So you need to if you've got your frequencies, add them up one by one, and you should end up at the bottom with the total frequency, and then you plot your points on the end point of your ranges. So if it says it goes from like 10 to 20, you would plot your cumulative frequency on 20, and then so on. You join your points up with a freehand curve. Box plots, 5 key pieces of information you need. So you need the smallest number, you need the lower quartile, you need the median, upper quartile, and the highest number. Okay, unless they fall outside, or let me rephrase that, unless they are, anomalies, which, if they are, will be defined in the question. So don't worry about it unless it's spoken about in the question. Box plots just spoken about. Histograms, so you need frequency density. You plot, obviously, the width of your box, or your bars, is your range. The height is the frequency density. Now, frequency density, I'll write it on here. So frequency density, and this is, you need to remember this, is the frequency divided by the class width. So if your frequency was 20 and your width was 10, 20 divided by 10 is 2. Okay? Averages and range next. I'm going through all these now, but quite a lot of these overlap, so I'm not going to go through these on every single one. Averages and range, so that would be mean, mode, median, and the range. And then you would also have to do that, not just with numbers, but also with tables. Sequences, so that would be, nth term, is this number in the sequence, so on. Forming and solving equations could come in loads of different loads of different questions. You've then got sharing into a ratio, so you need to divide by your total number of parts and then times by, let's say it's 2 to 3, times by 2, times by 3. Circles and sectors we're going to go through in a second. Pi r squared and pi times the diameter, or 2 times pi times r. And then if you're doing a sector or arc length, you need to times either of those by the angle out of 360. Increase and decrease by percentages. You should have a percentage button on your calculator you can use, or what you can do is you can use multipliers, so add your percentage or subtract it if it's decreased from 100, change to a decimal. That's your multiplier, that will find you that amount. Solve linear equations, we've done that in the starter. Well, I say we've done it, we did changing the subject, which follows the same format, except solve means find out what the letter is. So again, you'll end up with y equals, but you'll have some number that it's equal to, or something else equal. Multiple ratio problem solving, so again, related to ratio, but problem solving. Perimeters, distance around the outside. Types of graph, cubic. So a cubic graph generally looks like this. Okay, reciprocal is going to look like this. Exponential graph is going to look like this. So it starts off really small, gets bigger. The general formats. Now obviously if you have transformations of those, or say you have an exponential where the number to the power of x, say it's like something like 0.8, so less than 1, between 0 and 1, it will actually look slightly different to that. You will end up starting large and getting smaller, okay, because a small number to a power will decrease each time. Volume of 3D shapes, so that could be cuboids, prisms. I've done that in previous weeks as well, I'm sure I have. It could be spheres, it could be cones, which you should get some formulas for. And then Venn diagrams we did in the starter, a little bit, how they work at least. Okay, now foundation, this is, That was AQA higher. This is NXL higher. Got them in a different order to what I thought. Okay, so standard form, number between 1 and 10, times by 10 with a power, quadratic graphs, so they look like a U shape or upside down U, speed, distance, time, so that could be, well, speed is distance divided by time. Circle we talked about already, transformations and invariant points. So I went through some transformations on the session on Tuesday before paper 2. Invariant points are points that haven't moved after a transformation. Averages and range we've spoken about, types of graphs we've spoken about, density, mass and volume we've spoken about, recurring decimals to fractions. So that will need to be a proof. You need to start off with x equals and then get 10x, 100 or 1000x, subtract it and divide by your number. Expanding triple brackets. Expand 2 of the brackets first of all and then times everything in your answer by one thing in the last bracket and then times everything by the other thing in the last bracket. Solve a quadratic we've spoken about. Algebraic proof. So for that you need to know how you would define like an even number or an odd number. Completing the square. So you would need to say I had something like x squared minus 4x plus 16. So to complete the square you have one bracket with x minus and half the number in front of your x, so minus 2 squared. Now if I square negative 2 I get plus 4, so I need to take away that 4 because I just want this bit to be the first 2 terms, so that will give me x squared minus 2x minus 2x, which is minus 4x, minus 2 times minus 2 is plus 4, so take away the 4, and then I've got this bit here, so bring that down, I've got plus 16. Then I can simplify this, so x minus 2 squared minus 4 plus 16 is going to give me plus 12. So that's the completed square. Speed time graphs we've spoken about before. General iterative processes. So that is x and then little n plus 1. xn plus 1 is equal to xn plus 2. Something like that. Where what you do is xn is your answer, your previous answer, do what you need to do, so do what the function says, that gives you the next number. Cosine rule we've done at the start, half AB sine C we've talked about. Geometric proof, so that could be something like, you know, you're timesing by a number each time, and again you're having to do some kind of proof with that. Box plots we've spoken about. But geometric proof is they can ask loads of different questions, so in terms of thinking about one, it's a little bit difficult because they don't follow a standard format. Okay, right. Next one, so foundation. This is NXL, and then we'll look at AQA foundation. Standard form, quadratic graphs again, increase or decrease by percentage, direct proportion, SOHCAHTOA, so trigonometry, make sure you remember those and learn those if you haven't already. High score and factor, low score and multiple. Substitution, which we've looked at. So we've looked at in previous sessions, so that's basically changing your letter to the number it tells you. Expanding and simplifying brackets. Percentage profit or percentage change. So that's your change or profit divided by the original amount times 100. Fraction of an amount we've spoken about. Writing is a ratio, so 2 apples, 3 pears, that's a ratio of apples to pears, 2 to 3. 1 to n means you've just got to divide one side by whatever number it is to get it to 1, divide the other side by the same number, and that will give you n. Now n might not be a whole number, it might be a decimal. Usually you don't have decimals in ratio, but in this case, with that type of question, that is fine. Circles and sectors we've talked about. Angles in polygons. So that is going to be, it could be interior angles. Now if you have an interior angle, it's going to be n plus 2, n is your number of sides, not n plus 2, n minus 2, sorry, n minus 2, and then that's times by 180. Now the n minus 2, that's to do with there being 2 fewer triangles in the shape than the number of sides, and a triangle has 180 degrees in it, so that will give you the total angles in the shape. To then get an interior angle, you need to divide that by the number of sides. Now what might be easier is working out the exterior angle if you've got a regular polygon. Now this only works with a regular polygon. So the exterior angles all add up to 360, so if you do 360 divided by your number of sides, that will give you the exterior. Now the exterior angle, add the interior angle, gives you 180 degrees. So that's generally easier than having to use this formula, especially if you're doing a problem in reverse. So they give you the angle, like an interior angle of a regular shape, and they ask you to find out how many sides it's got. Find the exterior, divide it by 360 divided by the exterior angle. Changing the subject we've done. Currency and unit conversions work in a very similar way to direct proportion. Angles in a triangle is 180. Okay. Perimeter, we've spoken about that. Square and cube numbers, you need to know them. So 2 squared is 2 times 2, 5 cubed is 5 times 5 times 5. Prime numbers, make sure you learn them. Indices we've spoken about. Now you might have negative indices, which means you do the reciprocal and then you do the top and the bottom number of your fraction to the power that is there. So if it's -2, you flip your fraction, square, top number, square, bottom number. Place value, fractions, decimals, percentages, make sure you know how to convert between them. Stem and leaf diagrams, and make sure to remember your key for these. So you put in the side, or your kind of, not headings, but the bits down the side are your first number. So if you're working, if all your numbers are in the tens, that would be along the left hand side. Your first column is your tens, and then you'd have your units after. Pie charts, bar charts, and pictograms. Pie charts, remember it's out 360 degrees. Bar charts, make sure you leave spaces in between because it's not a histogram. And pictograms, make sure if it's a fraction, you do a fraction of your picture. Okay, now there will be very similar things on AQA Foundation. So here we've got averages again, error intervals, standard form, solving linear inequalities, circles and sectors, trigonometry, direct inverse proportion, constructions and loci. Make sure you remember your compass, and if you haven't already, watch some videos on these from places like Maths Genie, Corbett Maths. It is relatively straightforward. I say relatively. That's if you know it, if you've practiced it. If you haven't, it'll be quite tricky. You almost certainly won't know what to do. Approximations, round each of your numbers to one significant figure, generally, unless you're square rooting, round to the nearest square number, then square root. Use of a calculator, make sure you've practiced using your calculator with things like squaring, square rooting, fraction buttons, and so on. Change the subject we've looked at, solving linear equations we've spoken about. Bearings, I've looked at these in these sessions before. You measure from the north line and you go clockwise. Pythagoras, pie charts, approximations, again that's been put there twice, I think that's a mistake. Drawing and using straight line graphs, so like y equals mx plus c, how to draw those. Substitute your values into your calculator using the formula or the equation they give you, then write down the y coordinates for each of the x's, basically fill in a table. They will almost certainly give you a table. Plot the coordinates, straight line through them. If they're not all on a straight line, you've gone wrong somewhere, so make sure you go back and check. Scales, so it might say 1 centimetre is 100 metres, something like that. Again, that's direct proportion. Metric units, again, make sure you know your conversions, but if you do, it's direct proportion. Parts of a circle, and then symmetry. So that could be rotational, could be lines of symmetry. Right, now I've gone through all of those, and you can see the other 4 and 3 star ones. I'm going to go practice some of these questions. Okay. So starting off with circles and sectors, because that is something which is on all of the papers, so everybody needs to know that. Straighten the camera up a little bit. A circle has radius 5, work out the circumference. Circumference is pi times by the diameter. Now, if the radius is 5, the diameter, double that, is 10 centimetres. So the circumference is pi times by 10, and I'm going to write that as a decimal because This would be on the calculator paper, so they're going to ask you to write it to a certain number of decimal places. Let's go with 1. So 31.4, and that's going to be centimetres to 1 decimal place. It's not squared because circumference is the distance around the outside. Area of the circle, so area is pi times by the radius squared. So pi times by 5 squared gives me 25 pi. I'm doing it in my head because it is quite straightforward. S to D, 78.5, and that is centimetres squared because it's area, and that's 1 decimal place. What percentage of this square is shaded? Now we've got to read the rest of the question. So circle diameter 20 centimetres is drawn inside a square. That means this side is the same as this side as the width. Now the width must be the same as the diameter of the circle because the 4 sides of the square touch the circle. So that means that's 20, that's 20. So the area of the square is 20 times 20, which is 400 centimetres squared. Now the next bit is working out the area of the circle. So area of circle is pi times by r squared. Now the radius must be half of this 20, radius must be 10, so pi times 10 squared is equal to 100 pi. So I'll write that as 100 pi now because that's not my final answer, that's part of the working out. And again, that's centimetres squared. It says what percentage of the square is shaded. So what percentage of the square is shaded? Now, to work out the bit that's shaded, I need to do the square, take away the circle. So shaded part of the square is going to be 400 because that's the whole square. Take away the circle, which is 100 pi. And I'm going to leave it as that at the minute because that's not my final answer, so I don't want to change that to a decimal if I can help it. Okay, now percentage of the square is shaded. So the bit that is shaded is 400 minus 100 pi. Now I need to do that as a fraction of the square. Now the square is 400. If I type that into my calculator and press S to D, it will give me a decimal. I need a percentage, so times that by 100 will give me a percentage. So type all of that in. 400 minus 100 pi divided by 400 times by 100. 21.46. I'll give it to 1 decimal place again. So 21.5% is my answer. Okay. Moving on to some other questions on circles. So these are sectors, so areas of sectors and arc length. Show the length of the arc of AB, is 5.24 centimetres to 3 significant figures. Now to get the arc length I need to do the full circumference times by the angle over 360. So angle over 360, that's theta, not 0. That stands for angle generally. So times by pi times by diameter. Okay, now it says show the length of the arc. Now the diameter, if the radius, because that goes from the centre to the edge, the radius is 6, the diameter has to be 12. So I've got 50, my angle, over 360 times pi times by the whole diameter would be 12. That will give me the arc length, which should be 5.24 to 3 significant figures. 50 over 360 times by pi times by 12 is 5/3 pi, which is 5.24 to 3 significant figures, centimetres. Find the area. Now to find the area, it's angle over 360 times by pi times by radius squared. So again, 50 over 360 times by pi, this time times by 6 squared. Okay, so 50 over 360 times pi times by 6 squared is 5 pi. I'll put it as a decimal, 15.7 centimetres squared to 1 decimal place. Okay. Now the next question says calculate the perimeter of the sector. So we're told, well, we're not given an angle, but we're told the area of the sector. So think about how we can go from there to working out the angle and then working out the perimeter. Make sure you're drinking lots of water today if it's as hot where you are as it is where I am. I think it's going to get to about 28, 29 degrees today. So make sure you're drinking lots of water. Okay, so we're given the area. Now what we can do is we can use this formula, work backwards to find out the angle. So the angle over 360 times by pi times by radius, which is 7 squared, is equal to 40. Okay, so I need to basically solve this. Divide both sides by 7 squared, or divide by basically 49. So I'm going to get theta over 360 times pi is equal to, the calculator's just going to give it to me as 40 over 49, but I'll do it anyway. Yeah, 40 over 49. Keep it like that. Fractions are always better to use than decimals. Okay, so don't change it to a decimal. Don't be tempted to do that until, obviously, your answer. Divide by pi on both sides. And we get theta over 360 is equal to 40 over 49 divided by pi. Now I'm going to get a decimal. So what I'm going to have to do at this point is write 0.259 dot dot dot. Leave that number on your calculator. Make sure you do write the dot 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 bit. And if you're going to take that off your calculator, write all the digits down. Now times both sides by 360. And we're still not going to get something nice, but it will give us the angle, the exact angle. So 93.54 dot dot dot. Okay. Now, with this, don't take the angle off your calculator. If you do, make sure you write down all the digits. Now we can start working out the perimeter, which is what we need, because we can work out the arc length here. We can work out AB, but remember with the perimeter, it's all the way around your shape. So you've got to work out AB, add 7, add a 7. Okay, so arc length, we need to do angle over 360 times by pi times by diameter, because we're doing the circumference, we want a fraction of it. So the circumference is going to be, well, sorry, the diameter is going to be double 7, so that's 14. And then we need to add on to this 2 7s. Add a 7, add a 7, because we want the full perimeter. I'm just going to change this theta for the actual angle. 93.54 dot dot dot. Okay, so now I'm going to plug that in, and I'm just going to do answer button over 360 times by pi times by 14 plus 7 plus 7. And you might want to put that first bit in brackets. It doesn't actually matter because it will do the multiplication first, but you might just think, I want to work that bit out and then I want to add those on, and that might just be a way of reassuring yourself that's what the calculator is doing. Okay, and we end up with this 25, the three significant figures, 25.4. And that is the perimeter, so that's going to be centimetres, and that is 3 significant figures. There we go. Okay, moving on. Not that page. Standard form was another thing which was on, I don't think every paper, but it was on quite a few. And you know, we've just gone through them, so you know, it is on, I think, 3 out of the 4. Now remember, those are just predictions, so even though, you know, standard form might have not been on your predicted topics for your paper, that doesn't mean it can't be on the test. Okay, Give your answers in standard form. Now remember, you've got your calculator, so the first thing to try is to plug these in on your calculator. And I recommend writing times 10 and doing your power this way instead of using this standard form button. I don't like it because it gives you a weird notation. It doesn't look like how it's written on the page. So my calculator's given it to me like this, which means I'm going to have to change that into standard form. So you definitely have to know how to do that. So that in standard form will be 3.027 times by 10. Now I'd have to move it 1, 2, 3, 4 places. So times 10 to the power of 4. Okay, next question. Type this in. 5 times 10 to the power of 6 times 7 times 10 to the power of 8. 3.5 times 10 to the power of 15. It's done it for us. Now it will do it for you if the number is big enough. If it's not big enough, it won't do it for you. And there are some ways you can try and manipulate it, but it doesn't always work. So if I try and show you 3270. Now these arrow buttons here, just above these buttons, they can work sometimes. Not that one. So you see there, it's made it smaller, and it has got times 10, but that's not in standard form because it's not a number between 1 and 10. So sometimes that can help, but sometimes it won't. Last one, square root 0.621 times 7.94 divided by 0.334, and that gives me this number, but it says estimate. It doesn't say anything about standard form, so I need to read the question. Now estimation, round these generally to one significant figure, so that would be 0.6. First digit is 7, look after that, or first non-zero digit I should say, is 7, look after it's a 9, so that's going to round up to 8, divided by, first non-zero digit is 3, the next one is a 3, so that 3 stays the same, divided by 0.3, and then we square root it. So now I can type it in my calculator. If you type it in and write down the exact answer, so type in exactly, write the exact answer, you won't get any marks. So make sure you look out for this word. Okay, it says estimate, make sure you do estimate the numbers. Okay, next question on here is a worded one. Okay, now again, you've got your calculator, so the main issue with this, or the main thing, is to make sure you're doing the right operation. So a person's heart beats approximately 10 to the 5 times each day. So in terms of standard form, that's 1 times 10 to the power of 5. A person lives for approximately 81 years. Work out an estimate for the number of times a person's heart beats in their lifetime. Give your answer in standard form, correct to 2 significant figures. Now, although this word says estimate in it, because of the nature of the question, we don't need to actually round any of these numbers. We don't need to round 81 because it's already approximate, and this 10 to the power of 5 is already approximate. Okay, it's already been rounded, if you like. So we don't need to actually round any of these numbers, unlike the last question. But what we need to do is make sure we are doing the correct thing, the correct operations. So work out an estimate for the number of times a heart beats in their lifetime. So a person lives for 81 years. Now, this is in days. So a person's heart beats approximately 10 to the power of 5 times each day. I mean, that's quite a large number, really, isn't it? I mean, it says give our answer in standard form, so be aware of that. So 10 to the power of 5 is, what is that, 100,000 times a day. Wow. Okay. That's per day. Now we need to change 81 years into days. So 81 years. Now in a year there's 365 days. So 81 times 365. That will give me how many days? We've got to have the same unit. So 29565. Okay, so that's how many days. We need to times that by how many beats per day. So we're going to get 29565 times 10 to the power of 5. That's how many beats would happen in a person's lifetime approximately. but that's not in standard form. So what you might want to do is change that to standard form. So 2.9565 times 10 to the power of 1, 2, 3, 4, and then times it by the 10 to the power of 5. 2.95, I'll start that again, 2.9565 times 10 to the power of 4, and then that is times by 10 to the power of 5, which gives me a final answer of 2.9565 times 10. Add your powers to the power of 9. Okay. Now another way you could have done that, I'll write this over here, 29565 times 10 to the power of 5. You would need to divide this by 10 once, twice, 3, 4 times. So divide by 10 4 times to get 2.9565. Now to keep the number the same, if I divide by 10 to the power of 4 here, I need to times by 10 to the power of 4 here, so that hasn't changed actually what the number is. Now that gives me again the same thing, 10 to the power of 9. Okay, next question is to have a look at. So we've got some more standard form ones, then averages and range we're going to look at. Write down the name of the planet with the greatest mass. So you're looking at the mass here in my table. Now the powers are the most important thing. So first things first, you're looking for the one with the highest power of 10. Okay, because no matter what the rest of the digits are, the highest power will be the biggest number. So we've got times 10 to the 27. Yes, so it's going to be this one, 1.898 times 10 to the 27, which is Jupiter. Find the difference between the mass of Venus and the mass of Mercury. So Venus is times 10 to the 24, Mercury is times 10 to the 23, so we've got the 4.869 times 10 to the 24 minus Mercury is 3.302 times 10 to the 23. So if I type that into my calculator again, make sure you use your calculator, 869 times 10 to the 24 minus 3.302 times 10 to the power of 23. That gives me this number, which is in standard form, and I'm going to leave it in standard form, obviously, because, well, I say obviously, because that is going to be times 10, 24 times. That's a huge number to try and write down. So 4.5388 times 10 to the power of 24 is my answer. Now before I move on, I just want to quickly touch on the negative powers. So if you had something like 3.74 times 10 to the negative 3, that means you divide by 10 3 times, because the negative power means you do the reciprocal. So that means you're actually timesing by 1 over 10, which is the same as dividing by 10 3 times, because it's still cubed. So that would give you, move the decimal point to the left 3 times. So 1, 2, 3 goes down here, fill in your gaps. So it'd be 0.00374. Okay, right, averages and range. So the mean, you add them all up and divide by how many numbers you've got. The mode is the most common number, the one that appears the most, or it could be, doesn't have to be numbers, it could be colours, anything. It could be shoe sizes, which again are numbers, but they're discrete data because you only have certain amounts. Median is, put them in order from smallest to largest, it's the number in the middle. And then the range is the biggest number, take away the smallest number. So for the median, first thing you have to do is put them in order from smallest to largest, or largest to smallest, doesn't really matter. So 11, 11, 13, 22, and then 58. And if you've got a small list like this, count in your head 1, 2, 1, 2, it's the number in the middle. If you've got two numbers in the middle, you go halfway in between them. If you're not sure how to do that, add the two numbers together and half it. the range of the 5 amounts. Well, the biggest one's 58 and the smallest is 11. So 58 take 11, it's going to give me 47. Now range isn't an average, it's a measure of spread, how spread apart your data is. Okay. Next questions, and I'm going to do this page and then that will be time. That will be an hour done, which is probably enough maths. Well, enough maths for the moment at least. You might want to break and then to come back and then also do your own maths, focusing on what you need to focus on. If there's other things that I've gone through that you want to focus on, what I'll do at the end is I'll quickly run through the questions I've got and you can work on them or not, up to you. Right, now the methods I'm going to go through on this question are exactly the same as if the table had ranges. So say it went from like 0 to 5 here, 5 to 10, so on. Okay, so exactly the same method. The only difference is if you have the range, or if you have a range, you have to use the midpoint. Okay, we don't have a range, we're not going to do that. Find the modal number of points, and if this has a range in your table, it will say the modal class interval, which is the same thing. You just copy and paste the bit here. Mode is the one that appears the most. It's the one with the highest frequency, so that's 7, so it's 2. Total number of points scored. Frequency means how many. So on 4 occasions there was 0 points scored, so that gives me a total of 0. On 3 occasions 1 point was scored, so that's a total of the 1s of 3. Total of the 2s, 7 lots of 2 is 14, 5 lots of 3 is 15, 6 lots of 4, 24, and 5 lots of 5, 25. So that's the total of my 5s, total of my 4s, 3s, 2s, 1s, 0s. I need the total of everything, so add those up. So I've got 0, add 3, add 14, add 15, add 24, add 25, gives me 81. So that's my answer here. Work out the mean number of points scored. Now, the mean is your total divided by how many? Or the total frequency, if you like. So I've got my total number of points scored. To find out how many, I need to add up my frequencies. So my total of my frequencies, 4 add 3, add 7, add 5, add 6, add 5 is 30. So that's 30, so I need to do 81 divided by 30. 81 divided by 30 is 2.7. So the mean is 2.7. If you look at your numbers, that makes sense. The mean has to be somewhere between the smallest and the biggest, and it will also have to be, it will also depend on the distribution of your frequencies here. Because I've got more numbers, i.e. higher frequencies at the top, or I should say rather the bottom of this table than these lower numbers up here, that means that my mean is going to be shifted from the midpoint up a little bit, which it is, 2.7. Now to find the median, usually like we've just done, you put your numbers in order and it's the number in the middle. Now to find the median in a table, what you need to do is find out how many numbers you've got, 30. Now there's a method for finding the position of the median. To find the position of the median, it depends on how many numbers you've got. So we've got 30. Now you add 1 to it and you half it. Okay. Now, if you don't believe me, try this with 3 numbers, with 5 numbers, with 7 numbers, and build it up, and you will see that this is always true. 30 add 1 is 31. Half of it is going to be 15.5. So I'm looking for what my 15.5th number is, i.e. my 15th number, my 16th number, go halfway between them if they're different. Which in most cases in a table, they won't be different. So, first 4 numbers are zeros. Okay, so I've got 0, 0, 0, 0. Next 3 numbers are 1s. 1, 1, 1. So in total now I'm up to 7 numbers. Another 7 numbers, so they're 2s. 2, 2, 2, 2, 2, 2, 2. Now I've got 14 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my 15th number must be a 3 and my 16th number must be a 3. Halfway between 3 and 3 is 3. So that's the position, that's not the median. Can't be, 'cause it's got to be somewhere in between here. 3 is the median. Okay, right, what I'm going to do now is I'll just run through and show you the rest of these questions that I had. These are exam questions from past papers, if you want to have a look at or focus on any of these topics. So there were some more averages questions up here, so that was an averages question. This is an averages question, which is a little bit more difficult. It's got ratios involved with it. Okay. Next questions are probability, because again, they were the next most common one across all the papers. So the probability that a fridge has a fault is 0.015, you can read that. Another probability question, sample spaces question. And then on the next page we have got tree diagrams and then conditional probability question. And then the final lots of questions I had were again on probability. This is to do with a Venn diagram, or suggested to use a Venn diagram, and this is an algebraic probability question which you might want to have a look at as well. Okay, thank you for watching, people that have tuned in, and thank you for watching if you watch this back later on. Please like and subscribe on the videos, because it tells me that these are useful, and obviously if it has been useful, yes, it will be up to watch later. So that's absolutely fine if you want to come back and watch it later. I did all the predictions, I went through those at the start, okay? So if you're interested in those, you can just, as soon as it's finished, in a moment, you should be able to go back to it and find it. Or if you're busy now, you can watch it later. Yes, thank you for watching, and I will be doing another stream Tuesday night with some last minute revision, last minute questions, last minute topics, last minute advice for, you know, how to get settled, how to calm yourself down, how to make sure you're okay for your exam, as you know, ready for it as you can be. Okay, right, I'll leave it there. Thanks for watching. See you in the next one. Bye bye.